Evening. Sorry for being late. Too much traffic. Sit down. Sit down. Okay, we have Anand online today. Is Anand? Okay, tell me, where did we stop last class? We were doing what? Work and energy. Completed. To start the chapter. Work and energy is completed. With numericals and all. So where did we stop? Yeah. Did we do review question? Do we have review question? Hmm? Review questions, did we do? No. What is the last topic we did? Power is completed. All right. So that means we'll start with review questions today. Okay, let's discuss. So anybody who has missed the topic, this will be a scope. This will be a good opportunity to complete any missed topic as well. So first question, we'll take turn. Start with you. When is work said to be done?
The object is displaced or is the same position.
When force acting on the object displaces it. Okay. So for work, we require two things. Force as well as displacement. All right. Second question, yourself. Question to read. Page number 58. We are doing review questions, classwork exercise. So question one, everyone got? When do we say work is done? When force acting on the object displaces the object. Only then, because if force acting on a wall, is the wall moving? No, then work is zero in that case, because displacement is zero. Okay. Now, we have discussed all the examples during the day. Yes. So what's the answer for this? Fs cos theta. Did you learn this? The chapter is over. पढ़ा था ना? So whenever, let's say, there is an object, okay, and a force is applied on it. So this object is displaced in this direction. Okay. In this case, force and displacement are in the same direction. So when force and displacement are in the same direction, the angle theta is 0 degree. Right? But if, let us say, this is the object, force is acting in this direction, and the displacement is here. So what is the angle here between force and displacement? Theta. Like pulling the luggage with a wheel. Right? So you are pulling the luggage like this, but where is the luggage moving? Horizontal. In that case, force is given by, work is given by this point. So allergen here. So really I'm sneezing. Did anybody do some dusting? before I came? Okay. Is this clear? Cos theta has a value. You have to remember. So if theta is equal to 0 degree, cos 0 is 1. Theta is equal to 90 degree, cos 90 is 0. If theta is equal to 180 degree, minus 1. So you're familiar with all this? Huh? So only these three angles value you will be required to know, if at all. So okay, question 2. Question 3.
Can I tell?
Joule, right? So because it is Newton meter is joule. So what is 1 joule? 1 joule is equal to 1 Newton into 1 meter. Okay, that's what. Yes. Take the next question.
When is work done positive?
Yes,
And this means they are allowed to infection.
correct. That is theta 0, right? Question 4. North, F, and S in same direction. Again. Okay, Anand, you take question 5. Unmute yourself.
Okay, sir. When is no work done by a force?
Yes. So three possibility: work depend on force, displacement, and cos theta. Right? So what are the three cases? Case 1, F equal to 0, S not equal to 0. Case 2, F not equal to 0, S equal to 0. Case 3, theta is equal to 90 degree between F and S. These are the three cases because cos 90 is 0. So where is this possible? Huh? What is the example of first case? When force does not act while displacement is taking place. So either the body is undergoing uniform motion. During uniform motion, there is no acceleration. Acceleration is 0, so force will be 0. Right? So body undergoing uniform motion. Right? And body is undergoing uniform motion, that is V constant. V constant means acceleration is 0. This means F0. Understood? So whenever we say uniform motion, all these things mean there is no net force acting on the body. What is the example of this? Like pushing a wall. Second example is pushing a wall. So force is not 0 in this case. You are applying some force, but there is no displacement. And here, so body undergoing uniform circular motion. Body in UCM. whenever the body is undergoing uniform circular motion, right? What is happening? The displacement and force. Force is in this direction towards center, whereas displacement is always perpendicular. Always. Okay, so these are examples where no work is done by a force. Question number 6.
Decline one energy.
Okay, so one by one. So we'll take turn, okay?
I have 6%.
Okay,
If the formula for work done by gravity when displacement is h,
okay. So for gravity, two motions are possible, downward or upward. So there are two for downward motion. Consider it fell from height h, right? So what is the force? What is its force or weight? Mg, and it comes from here to here, h. So force is mg, displacement is h. So what is the work done? F into h, which is mgh. Okay, for downward motion. Likewise, for upward motion, it will be minus mgh. Now, what is happening to the body? The downward force is mg, but now you have to apply equal force mg in the upward direction, right? So, but we are calculating work done by gravitational force. So mg is downward, h is up, so it is cos 180. So W is equal to mg h into cos 180, right? So what is it? Minus m. Because we are calculating work done by gravitational force, not the force which is lifting the body. So these are the two possibilities for work done by gravity. So question 7 has 6 sub items and everybody will take turn. So you start with energy. First you write it, then you start with that. Is that right? Start with energy. What is energy?
energy is the ability to do.
Correct. So everybody knows this, right? Ability to do work. So it is, right? What is energy? It is ability to do work. So what is next? 1 joule, we already did. What is 1 joule?
Sir, 1 Newton into 1 meters.
Yes. When 1 Newton of force displaces the object by 1 meter, the work done by the force is 1 joule. Third, kinetic energy. Correct. And what is the formula for kinetic energy? Half mv square. Okay. Energy due to motion. Fourth. Yes. Due to its change of position or configuration. Both change. Position, change of position or change of configuration. So how much is potential energy? We have to learn only gravitational potential energy. Okay. So whenever you do work on the body, the work done is stored as its potential energy. Only this is the formula for gravitational potential. No other potential energy you have to learn in this step. Anand,
Yes, sir.
power.
Sir, it is work upon time.
So it is defined as rate of work done. Rate of work done. So work and whenever work is done, energy spent. So it is also defined as rate of rate at which energy is spent. Rate of energy spent. Okay. Then it can also be written as, because work can be written as, since power is equal to W by T, this is equal to force into displacement upon T. And displacement upon time is velocity. So this is also formula for power in terms of force and velocity. Okay. So all these formulas are for power. Okay, Anand, you only take question 6. What is unit of power?
Sir. Unit of power. Watt.
So 1 watt, what is it?
1 work upon 1 time.
1 joule.
1 joule. Sorry.
When you say unit, write unit of every quantity. So when 1 joule of work is done in 1 second, okay, then we say the power consumed is 1 watt. Okay, right? So when 1 joule of energy is consumed in 1 second, then the power consumed is 1 watt. Power tells you how fast the energy is consumed. Okay, if less energy is consumed per unit time, then the power of the machine is low. So all the powerful machine will deliver more work because more energy means more work in less time. Understood? That's the significance of power. All right. So what is law of conservation of energy?
And cannot be destroyed, can never be changed for another.
Yes. From one form to other form. So what it means is total energy always remains constant. Okay? This is the meaning of energy conversion. So during free fall, of a body, we have demonstrated the law of conservation of energy for this case. So I'll slow down a bit. I guess you're right. So complete writing, then we come to it later also. With one more student, apart from Anand. Oh, this is it. Acha, that student did not come first time. Are you done writing? Okay, let's go to the next question, which is question number 9. Scalar quantity, because it is energy. So it doesn't have any direction. So it is scalar quantity. Question 9. What is scalar quantity? Then
On what factors is the work done by a force depend?
what is the formula for force? Huh? No. What is the formula for work? What factors work depend on? So what is the formula for work? Force, displacement, and so it depends on 3 things. Depends on force, depends on displacement, and cosine of angle between force and displacement. Depends on 3 things. Force, displacement, and cos theta. Cosine of angle between force and displacement. So this is how you write. So work is proportional to F, work is proportional to displacement, work is proportional to cos of theta. Where theta is angle between F and S. जो फॉर्मूला में राइट साइड में है तीनों चीज पे डिपेंड करता है वर्क इज प्रोपोर्शनल मतलब डिपेंड या नहीं प्रोपोर्शनल मतलब ये चेंज होगा तो उससे वर्क चेंज हो जाएगा है ना डिस्प्लेसमेंट चेंज होगा तो भी वर्क चेंज होगा कॉस थीटा चेंज होगा तो भी वर्क चेंज होगा so give example of positive and negative work
Work equals S.
yes example so freely falling body so positive work done by which force
Sir, positive work when it is in the same direction.
Yeah, so example, she gave the example freely falling object.
Hmm.
So positive work is done by which force? Work is always done by some force. Gravity.
Hmm.
Freely falling body pe, what force is acting?
Gravity.
Mg, gravitational force. Mg is the gravity. It is also the weight of the object. Weight and gravity are the same thing. Is that clear? And what is mathematically the formula for weight? F equal to mg. So this is gravity or weight. So mass of the object multiplied by acceleration due to gravity becomes gravitational force. Because force is mass into acceleration. Okay? So who is providing the acceleration? Gravity. That's why it is called acceleration due to gravity. Gravity is a force. And that gravitational force of the object is its weight. Our mass is different and our weight is different. Is that clear? So, it's an example of positive and negative work.
Sir, pulling water out of well.
Yes. Is it positive or negative?
Hmm.
Let's say pulling water out of well. So, who is pulling water out of well? Anand is pulling water out of well. So when you are pulling it up, so Anand is applying force in this direction, and the displacement is also in this direction. So Anand is doing positive work or negative work?
No, sir, not like that. When it is a pulley system, right? You pull it down and the water comes out.
That's okay. Pulley system is not here. Have you learned pulley system?
Yes.
Where have you learned pulley? I have not taught you yet.
No, but for basic, it has been taught in 7th.
And complex.
Pulley is, see, you're not pulling the bucket directly. The spring is pulling the bucket. Okay, let's say you have, so you are applying force on the string, and that is the tension. So basically, you are balancing tension in the string. When you are pulling it here, right? When you're pulling it down, okay, you're applying tension on the string. And here, tension is pulling the bucket up. It's a different concept. It's an advanced concept, so we are not doing this.
Okay.
Right now, when you are pulling the bucket up, so you are doing positive work because FNS. Okay, so Anand is doing positive work. But what about gravity? Gravity is acting down, and the displacement is up. So while Anand is pulling the bucket upward, work done by gravity is negative. Understood? So it is the force. Which force you are referring to? In the same process, different forces are doing different work. Like, so you can give this example, right? So when a body is thrown upward, okay, when the body is thrown upward, then also gravity is doing negative work, right? And the person who threw it up did positive work. Body will on its own will not go up. Okay. Now, let us say somebody is walking. So while walking, what is happening? Friction,
Force.
friction. So work done by friction is negative. Friction is acting in this direction, whereas displacement is taking place in this direction. Understood? This is what is happening. Is that clear? Whereas you are lifting your body ahead, you are pulling your weight forward, so you are doing positive work. Friction is doing negative work. Is that clear? So your muscular work is positive. Because who is lifting the body? You. Understood? So in the same physical process, different forces are doing different work. Is that clear? So I gave you example of positive and negative work. So work done by friction is negative. Work done by is negative. Okay. Work done by gravity is negative on upward moving objects. Okay. So work done by gravity is negative on upward moving objects. So question 11 and 12. 12 we have extensively covered. So this is both 11 and 12 are covered here. Thirteen we already did while doing power. 13 we already did in question 7. So derivation of kinetic energy we have already done during the theory. Okay. Has anyone missed that class? Derivation of kinetic energy. E kinetic equal to half mv square. Okay. So last few questions we have already covered in class, in theory, in detail. Right? Just read the question. If you need any help there, I can help you today. Just read question number 13, 14, 15, 16, 17. 17 we'll discuss. Yeah. We'll discuss 17. First you see from 14, 13 to 16.
Sir, 14, 15, and 16 can be done under the law of conservation of energy.
Only 16. Only 16 can be done under law of conservation of energy.
But one part of that,
No, that topic is done separately before the conservation. We have used that knowledge in conservation. Conservation follows that. So you refer your theory notes. Do you need any help in understanding how we arrived or derived these derivations?
no, sorry.
Okay. So let us discuss question number 17. Question number 17. What is the first? You have to identify what energy is converting when battery is used to light electric bulb. So when you let's say this is the bulb. So when you close the switch, let's say this is switch. This is battery. When you close the switch, what happens? The bulb will glow. So bulb has a filament, right? So this filament is shown like this. The bulb will begin to glow. So tell me, what is the conversion of energy taking place? So what kind of energy cell has?
Electrical to heat energy and heat energy to light energy.
Very good. Electrical to heat and light. And what is happening inside cell? And yes. Before electrical, it was chemical. Chemical reaction is causing these charges. Chemical to electrical, electrical to heat, and then light. Okay. So you can write chemical to electrical to heat and light. Okay. And this will exist simultaneously. All of things are happening simultaneously. It's like okay. So this is first part of the question. What is the second part? Solar cell generates electric current. What is the energy conversion? Huh? Solar to electric. So solar is which energy?
Sunlight or light.
Light to electrical energy. Do you have any other? Green leaves. So what happens in green leaves? What happens? Photosynthesis. What happens is light falls on from sun. So light energy to starch. Chemical. Wood is chemical. So this is light to light energy to chemical energy. So it is reaction, right? It is producing starch, some product. So this is what is nothing but photosynthesis. The physical process is photosynthesis. What is happening there? In this process, light energy is getting converted into starch. Okay. So that is the energy or food that the plant prepares for itself. All right. With this, we have completed the review questions. Okay. Now we'll do class 1 numericals. See, all the formulas that we have discussed will be used here. So I'll just give you the formula, you do the answer, or even you can do it yourself. What is to be found here? Work done, right? So what is the formula for it? When the angle is not given in the question, that means angle is 0. Okay? Or some description will be given. Then you judge what is the angle. So here it says it is in the direction of force. So cos 0 is 1. So you don't write cos 0. So what is the answer? What is it? Correct? So what is question 3? Everybody read. Is work done in this case? F is given 0.
But no, that is 0, so 4 by 6.
Friction less. Friction less. So therefore, W equal to 0. Oh, okay. 4. Why are you reading the paper? That's a lot. Oh yeah. 4. How will you do question 4? So whenever you read a question, write down the given data. That will give you the idea which formula to use. Write down the given data and write down what you are supposed to find.
Sir, force is equal to M into A, so we will do 30 into 9.8 to get force.
Correct. So this will be F into H. mgh. This is the formula. You are going against gravity, right? So force becomes weight here. Find the answer. What is the mass here? 30 kg. 9.97.
So 294 Newton. Oh no. Oh, that is force. 290.
Everyone understood how we did it? mgh. So in the vertical direction, if the motion is in upward or downward direction, this is the formula for work done. In the horizontal direction, it is F into S. In this case, cost
1058.
2058. Did you calculate?
Yes, sir.
Okay. So fifth, try fifth question. Very good. I see the first page. Turn the page back. Okay. Have you done the calculations? No. Do the calculations.
Sir, 3200.
How to do question 5? What is given? 400 Newton is what? The weight. Oh, sorry, the weight. What is the weight? The gravity. mg. What is weight? mg. mg is given now. Now no need to write multiply gravity separately. Okay. So what is mg here? 400 Newton. This is 400. What is the height? 8 meter. Correct? So the person is lifting himself 8 meter up. So how much is this? Newton meter cube. So weight given means mg is given to you. Everybody understood? Question 6, you have to calculate power. What is power? Work upon time. What kind of work the machine is doing? So it is the pump which is taking 20 seconds to raise 120 kg of water to tank. So it is lifting the water up. So work done for lifting up will be what? mgh. So how much water it is lifting? 120 kg. The acceleration due to gravity you have to use is 9.8. What is the height? 30 meter. And time is 20 seconds. So what you're calculating is power. When you solve all that, you should get 1764 watt. Just verify that. So today we'll stop here only. So we have done the full chapter revision as well as lot of questions. Okay, so I'll see you in the next class now. We'll try some homework question. Next class, you should come with some homework questions now. Okay, try. You don't get it, it's okay, you can ask. But don't try. Bring your homework on all of it. Okay, it could be same classwork with the questions attended. Is that clear?